The SpaceX Crew Dragon is the first spacecraft from a private company to take humans into space. In this video, we're going to take a look inside and see how it works. Then we'll see the launch pad, the journey into space, and how it docks to the International Space Station. Dragon SpaceX, you are go for launch. We're about to learn about an incredible piece of engineering that has overcome significant challenges. To solve these challenges, engineers need problem-solving skills that take time to develop. This is why I'm glad to have this video sponsored by Brilliant.org. With Brilliant, you can learn math and science interactively. You can actively try things out and understand why things work the way that they do. Maybe you're a professional and want to level up your skills, or maybe you're still in grade school and want a better way to understand math. Brilliant has thousands of lessons to choose from in a variety of different areas, and you can learn anytime, anywhere. I've really enjoyed some of the math lessons because you get to see things in a way that just won't happen with a textbook. You can try everything Brilliant has to offer for free for 30 days by going to brilliant.org/JaredOwen. The first 200 people will get 20% off Brilliant's annual premium membership. The Crew Dragon is a human-rated spacecraft. This means it's capable of carrying humans into space. It was created by a United States private company called SpaceX. The company has its headquarters in Hawthorne, California. Up until now, space exploration has been done by government agencies who have billions of dollars to spend. SpaceX is really the first private company to break through this barrier. They develop both rockets and spacecraft on their own. But of course, NASA is now one of the largest customers of SpaceX. Alright, for some background, this is the International Space Station, or ISS for short. It's been in use since the early 2000s and it must be continuously staffed by astronauts going to and from the station. To get a ride to the ISS, astronauts could launch on either the United States Space Shuttle or the Russian Soyuz spacecraft. The Space Shuttle is no longer in operation. It was retired in 2011. After that, the Soyuz was the only way to travel to the ISS. There was no other spacecraft available to take humans into space. The year 2020 changed all of this. The Crew Dragon flew astronauts once again from American soil. The Dragon spacecraft has a few different versions. First came Dragon 1. This was a cargo spacecraft that brought supplies to and from the ISS. It had more than 20 flights bringing cargo to the station. This version of the spacecraft could not carry humans, only cargo. Then came the Dragon 2. This has two versions, the Cargo Dragon and the Crew Dragon. The Crew Dragon can carry people and cargo into space. Cargo Dragon looks very similar, but it can only hold cargo. So it doesn't need life support, aboard engines, or controls inside the vehicle. For this video, we'll be focusing on the Crew Dragon. That's the part that's most exciting to me, bringing humans into space. The Crew Dragon is split up into two parts. This is the capsule, and this is the trunk. The capsule is also known as the pressurized section. Inside, there's air to breathe, and they keep the temperature nice and comfortable for the crew. This is the nose cone. It's closed for the launch, but they will immediately open it up once they are in space. This exposes some sensors, thrusters, and the docking mechanism that will be used to attach to the ISS. The Dragon capsule has 16 Draco thrusters, 12 of them on the side, and then 4 more up towards the top. Draco thrusters are used to change the orientation of the spacecraft. They are also used to change the spacecraft's orbit, so they can reach the ISS at the beginning of a mission, and then deorbit at the end of a mission and come back to Earth. Additionally, there are 8 Super Draco engines, and these are significantly more powerful. If there is an emergency on the launch pad, all the way up until they are in orbit, the Super Draco engines can quickly get the crew to safety. On the bottom is the heat shield. This will protect the crew as they enter the Earth's atmosphere at the end of the mission. At one point, SpaceX had plans to have landing legs and extend them through the heat shield. This is so that the capsule could touch down on land. This would have been really neat to see. However, due to cost, complexity, and time schedule, SpaceX turned away from this idea and decided to do a splashdown in the water like other NASA spacecraft have done in the past. The bottom half of the spacecraft is called the trunk. There's room for cargo in here, and it helps support the spacecraft during the launch. The white half of the trunk has the radiator panels, which help remove heat from the spacecraft. The other side covered in blue is the solar panels. This generates power for the Dragon capsule. The previous version of Dragon had solar panels that would unfold once in space. This can be problematic if the panels ever fail to unfold. So it's kind of nice to have the solar panels directly on the side. Just point it towards the sun and you've got power. The trunk stays attached for the entire mission. It's only detached at the very end, about an hour before splashdown. The trunk does not have a heat shield. It will fall back to the Earth and burn up as it enters the Earth's atmosphere. To enter the capsule, astronauts use the side hatch. The Dragon capsule was designed to fit up to 7 people inside. However, NASA has chosen to use only 4 of the seats. This leaves more room to carry cargo underneath the seats. The Crew Dragon has been described as a modern spacecraft. The seats are customized to the body of each astronaut, and there's a lot of room. Compare this to the Soyuz spacecraft, which, well, see for yourself. There's not a lot of room in there. If I had the choice, I would choose the Crew Dragon. Once the astronauts are fully strapped in, these seats will be rotated. The Crew Dragon can be controlled by the 3 touchscreen displays. Up until this point, most spacecraft have had tons of physical buttons, lots of knobs, switches, and dials. SpaceX has decided to go with the sleek, futuristic panels. There are a few physical controls just in case the panels fail. Most of the flying is done autonomously, which means most of it is done by the computers on board. If all goes well, the astronauts won't need to do much. Inside the cabin are several windows to look outside. And if you need to use the bathroom in space, you can use the toilet up towards the ceiling. We don't know too many details here, but let's just say privacy is somewhat limited. Right in the center is the docking hatch. This is where the astronauts will go through to get on board the ISS. We'll talk more about this later in the video. The bottom part of the capsule is referred to as the service section. This has more electronics and fuel tanks for the spacecraft. SpaceX designs their spacecraft to be reusable. Space is hard. The harshness of space and getting back down to Earth, this usually means that a spacecraft can only be used once, or at least that's how it's usually been done. You have to build a new one each time, and this costs a lot of money. With the Crew Dragon capsule, it's designed to be reused. There are a handful of vehicles that have been built so far, and they each have a serial number and they have a name as well. As of February 2023, some of these have been flown more than once, and Endeavour has been flown 3 times. The first time a Crew Dragon has been flown with a crew on board is May of 2020. There were 2 NASA astronauts on board that successfully docked to the International Space Station. Since then, the Crew Dragon has flown more flights, not just from NASA, but there was a flight of 4 civilians called Inspiration 4, and also a flight from a private space company called Axiom Space. At the time of this video, there are more missions planned as well. Things are definitely changing in the space industry. The Crew Dragon is launched on top of a Falcon 9 rocket, which is also made by SpaceX. This rocket gets its name because of the Millennium Falcon from Star Wars. That's pretty cool if you ask me. The launch takes place at Kennedy Space Center in Florida. This is Launch Complex 39A. It's where some of the most historic launches have taken place. But now SpaceX gets to use this launch pad, and it looks just a little bit different now. NASA has always transported rockets vertically to the launch pad. This is called the rollout. SpaceX has decided to do things just a little bit differently. Right next to the launch pad is the Horizontal Integration Facility. The Falcon 9 rocket and Crew Dragon are assembled in the horizontal position. Then they are slowly moved on top of the transporter erector. Then it's slowly lifted up to the vertical position. This usually takes several hours. The Russian Soyuz rocket is transported horizontally. They've been doing it this way since the 1960s. So this is nothing new, it's just a bit different from the way that NASA normally does things here in the US. On the day of the launch, the astronauts get into their SpaceX spacesuits, and then drive to the launch pad in a Tesla Model X. Elon Musk founded SpaceX and Tesla, so it's only fitting that astronauts ride in a Tesla on their way to the SpaceX launch. This is the fixed service structure. The astronauts ride up an elevator to get to the top. Then walk across the crew access arm. At the end is the White Room. Several technicians will be there to help the astronauts get into the capsule. This is called crew ingress. It's the word they use to describe the crew getting into the Dragon capsule. There are 4 seats. We have the commander, pilot, and then 2 mission specialists on the very ends. Once they are all strapped in, the seats recline to their laid-back position ready for the launch. The commander and pilot are now in a good position to use the 3 touch screens. They are in their seats about 2 hours before the launch. 45 minutes before the launch, the crew access arm is retracted. 35 minutes before the launch, the propellant begins loading into the Falcon 9 rocket. Falcon 9 is a 2-stage rocket. The first stage is powered by 9 Merlin 1D engines. That's also why they call it the Falcon 9, because there are 9 of these engines. The second stage is powered by a single Merlin vacuum engine. They call this a partially reusable rocket. The goal is to be fully reusable, but we're not there yet. The second stage is not reusable, or in other words, it's expendable. We don't have an easy way to get it back down to the ground. The first stage, however, is reusable, and in just a minute I'll show you how this works. So, our full rocket stack here, the only pieces that are reusable are the capsule and the first stage. You can sometimes tell if the first stage is being reused because it won't look quite as new. The most exciting part of every launch is the liftoff. Something you'll hear the controllers say is the word nominal. They'll say we have a nominal launch or a nominal separation. This is a very good word to hear. It means that everything is going as planned. The first stage shuts off at 2 minutes and 40 seconds. This is called MECO, or main engine cutoff. Then the first stage separates. Then the second stage fires up. This is what gets us into orbit around the Earth. While this second stage is firing, the first stage makes its way back to the ground. The first stage uses cold gas thrusters to reorient itself. This is called the flip maneuver. Grid fins also come out to help stabilize it. The first stage will come down over the ocean, so they will have a drone ship waiting at just the right spot. The entry burn helps to slow it down through the atmosphere. This only uses 3 of the Merlin engines. And just moments before touchdown, 1 more engine lights up for the landing burn, and then the landing legs are deployed for the final touchdown. The drone ship can make its way back to Florida, so this first stage can be reused on a future mission. The second stage is going to get the Dragon spacecraft into orbit around the Earth. This is called orbit insertion. Second stage cuts off at 8 minutes and 50 seconds. This is called SECO, or second engine cutoff. Shortly after, the second stage separates. As we talked about earlier, the second stage is not reused. It makes its way back down to the Earth and burns up in the atmosphere. Now keep in mind that a lot of these events are happening simultaneously. The Dragon spacecraft is on its own now. The nose cone opens up to expose the docking hatch, sensors, and thrusters. The crew will also be weightless for the first time. Once in orbit, it's time to catch up to the ISS. Most missions take around 24 hours for this to happen. The Draco thrusters are used several times to raise the orbit and close the distance to the station. To attach a spacecraft to the station, they do it in one of two ways. One is called berthing, and the other is called docking. First, let's talk about berthing. This is what the original Dragon spacecraft, or Dragon 1, would do. It would fly right up next to it, and the station's robotic arm would reach out and grab onto the spacecraft and help bring it in. This is called berthing. We just need a little help to join to the station. Docking is similar, but this time the spacecraft can do it all on its own without the help of a robotic arm. This is what the Crew Dragon does. It's called docking. Let's take a minute to look at the ISS again. The Dragon spacecraft will dock towards the front of the station. This is called Node 2, or the Harmony module. Attached to it is the Pressurized Mating Adapter, or PMA for short. There are 3 of them. PMA 1 is in the middle of the station, and then at the front is PMA 2 and PMA 3. The space shuttle actually was last docked here to PMA 2. This was back in 2011. Since then, they've added the International Docking Adapter, or IDA for short. This uses the newer docking mechanism that Crew Dragon is also using. So Crew Dragon is able to dock at 2 different locations. Most of the missions so far have docked to the very front of the station. In preparation for docking, Crew Dragon will extend the soft capture ring. Crew Dragon spacecraft will go through a series of waypoints, and these are points in space where they will stop and complete checks to ensure that the spacecraft is in good condition to proceed with docking. First, we have waypoint 0. This is 400 meters directly below the ISS. Next is waypoint 1. This is 220 meters directly in front of the station. They will line up along the docking axis, always pointing the capsule towards the docking port. Then they will slowly proceed to waypoint 2. This is 20 meters in front of the docking port. As it slowly moves in, you can see the Draco thrusters firing to keep it in line with the station. Once confirmed, then the spacecraft proceeds to dock, but moving only at a few centimeters per second. Once within 5 meters of the docking port, they have what's called CHOP, or Crew Hands-Off Point. If any aborts are needed at this point, it will be done completely by the onboard computers. Next, the soft capture ring on the Crew Dragon makes contact with the station. This is called soft capture. We've connected with the station, but it's not complete yet. The ring slowly retracts to pull the spacecraft in. This part is called hard capture. The 12 hooks will latch to firmly connect it to the station. It will take about 2 hours before docking is complete. First, we fill the vestibule with air. That's the area between the spacecraft and the station, right inside the International Docking Adapter. Once the temperature and pressure have normalized, then the APAS hatch can be opened. And then finally, the Dragon hatch. Now it's time to say hello to the astronauts that are already on board the station. My name's Jared. I create 3D animations to show and explain how things work. Click the cards to watch another video, or click here to subscribe. Thanks for watching, and I'll see you next time.